Hello, welcome to the presentation on oversampling to repair bias and imbalance simultaneously. My name is Martin Hirzel and my co-author is Parikshit. We will explain our algorithm on an example binary classification dataset with two classes, unfavorable and favorable outcomes, and two groups, privileged and unprivileged. Now, this dataset is imbalanced because there are fewer instances in the unfavorable class, 400, than in the favorable class, 600. Dividing 400 by 600 yields the class imbalance of 0.667. This dataset also exhibits bias because the favorable rate among the unprivileged group is only 100 out of 300, which is 0.333, whereas the favorable rate among the privileged group is 500 out of 700, or 0.714. Dividing those two numbers yields the disparate impact of 0.467. Now, of course, there are algorithms for repairing class imbalance, and there are algorithms for repairing group bias. However, in this paper, we argue that you have to repair both simultaneously, otherwise you will not get the desired result. Here's an example of doing it wrong. If you only repair the class imbalance by oversampling the unfavorable group so that it is now 600, has 600 instances, then you do get the desired perfect class imbalance of 1. However, in this example, you have actually made the disparate impact worse at 0.4. So you have exacerbated the bias in the data. Of course, you don't want to do that. Now, one thing that you could use our new algorithm for is to just repair one or the other separately, or you can repair both simultaneously. Either way, what you do is you have a desired new class imbalance and disparate impact, and you then solve those equations for the desired intersection sizes. For instance, if you want the class imbalance to be 1, but the disparate impact to be the same as it was in the original data set, then one solution would be as shown here on the left. On the other hand, if you want both perfect class imbalance and perfect disparate impact, then this example shows a solution. And our algorithm is more general because it can give you any point in between on a continuous spectrum. Our algorithm is called Orbis. Here's how it works. The input to the algorithm is a dataset, xy, along with a trainable estimator. As usual, the first thing you want to do is do a train test split on the data into x-train, y-train, and x-test, y-test. Now, what we do next is we relabel the dataset by computing what we call the diaresis labels, the y with the two dots on top. And these diaresis labels encode not just the classes, but the classes as well as the groups simultaneously. Once you have the diaresis labels, you can pick the new sizes by computing them, solving for the equations for disparate impact and group imbalance. And then you can actually oversample the dataset. We are using SMOTE for oversampling, which gives you a new x orbis and diaresis y orbis. Now all you have to do is do the inverse relabel to recover the original class labels. And now you have a training dataset, and you can take the trainable estimator and train it on that dataset to obtain a trained estimator. And of course, the next step is to evaluate that trained estimator by making predictions on the test data and finally scoring the results of those predictions. Our algorithm introduces repair level hyperparameters, one for bias and the other for imbalance. These hyperparameters can guarantee the desired effect on the training data, but not on estimators trained on that training data. Our algorithm assumes binary class labels. It does not assume a single binary protected attribute. However, when there are multiple or non-binary protected attributes, it will internally binarize them. We conducted an empirical study on 12 fairness datasets with comparison against 5 other imbalance mitigators and 9 other bias mitigators, and as well as experiments with 5 different ways to blend two metrics together for a single objective AUTOML, and our new Orbis algorithm performed well in all of these experiments. Finally, the implementation of Orbis is available on the Lale GitHub repo.